Well, another thing that we have to consider when it comes to inverse functions, the inverse trig functions, are the compositions of inverse functions. For example, right here, let's say that we're interested in determining what do we mean by sine of the arc sine of x. Well, typically we should say the following. As long as x is a value limited to being between -1 and +1, then this should just simply equal x. Now, how can I go about proving that to you? Well, I kind of think about it this way. If I had a right triangle, let's say I put it here in the first quadrant, there is some angle theta whose sine is equal to x, right? So in other words, just remove the sine from the outside right here. If I say theta is equal to the arc sine of x, well then the sine of the angle theta should be equal to x, right? That's what we're saying, right? X is the ratio of opposite to adjacent within that right triangle, and its arc sine is going to give us the angle for which that's true. So what am I saying? If I say sine of the arc sine of x, I'm just saying sine of the angle theta, right? Well, what is sine of the angle theta? Well, we've already established it, right? We said it's the opposite side x, hypotenuse 1, so that's x, right? So in other words, what we've just shown is that we're going to be able to undo one of these. Now, you do have to be careful. Again, it is important that x is between -1 and +1. If somebody wrote for you, please evaluate the sine of the arc sine of 2. Arc sine. Let me try that again. Well, that's a terrible way to spell arc sine. All right, arc sine of 2, right? Then at this point we'd have to say, well, that's undefined, right? Why? Well, remember, it falls outside of this range, right? So in this case, right, we can't be doing that. But as long as the value is between -1 and +1, we're fine. All right, cosine of the arc, cosine of x. Same deal. As long as x is a value between -1 and +1, then there is some angle theta. I'm going to put it over here in the second quadrant, right, because cosine is in the first and second quadrants between 0 and pi. So let's say I pick some angle theta over here. Well, this is the kind of angle theta for which the ratio of adjacent to hypotenuse is x, right? And so if that's the case, if theta is the arc cosine in this case of x, well then there's some angle theta whose cosine is x. Right? So saying the cosine of the arc sine of x is like saying cosine of theta. Right? And we just said it, that's x, right? As long as x is between -1 and +1, that's true. Same thing again for arctangent of x, provided that x is a value somewhere in a set of real numbers from -infinity to +infinity, then there exists some angle theta on the interval from -pi/2 to +pi/2, such that the ratio of opposite to adjacent is x. Right? So, well, if we say theta is the arctangent of that angle x, then we're taking the tangent of that angle theta, and the ratio of tangent is going to be opposite adjacent, still x. Right? So this is x. This is x. These are just situations in which we are reducing a function and its inverse. Would it work the other way around? Well, that's an interesting question. What would happen if I said in our first case over here, could we take the arc sine of the sine of x if x is an angle? Well, now that's a different story, right? Because in this case, as long as x is between negative pi over 2 and positive pi over 2, that's fine, right? But we're going to have a little bit of a difference if x is outside of this range. Remember, we can take the sine of any angle. Well, if the angle is between negative pi over 2 and positive pi over 2, these two will just undo each other. But if it's something else, well, we're going to have a different situation. We'll talk about that soon. So we can deal with some similar situations for our cosine and arctangent compositions, but we'll deal with that shortly.